Hey guys, welcome back to my channel, and now I will summarize the chapter 7 entitled IP addressing. IPv4 network addresses, topic 7.1. IPv4 addresses. Binary is a numbering system that consists of numbers 0 and 1 called bits. In contrast, the decimal numbering system consists of 10 digits consisting of the numbers 0 to 9. Each address consists of a string of 32 bits divided into 4 sections called octets. Each octet contains 8 bits or 1 byte separated with a dot or 1 dot. For example, PC1 in the figure is assigned IPv4 address. Working with binary numbers can be challenging for ease of by people. IPv4 addresses are commonly expressed in data decimal notation as shown in figure 2. For a solid understanding of network addressing, it is necessary to know binary addressing and gain practical skills. Network and host port portions. Understanding binary notation is important when determining if two hosts are in the same network. It is necessary to look at the 32-bit stream. Within the 32-bit stream, a portion of the bits identify the network, and a portion of the bits identify the host as shown in the figure. The bit within the network portion of the address must be identical for all devices that reside in the same network. The bits within the host portion of the address must be unique to identify a specific host within a network. The subnet mask is the most important. We all know the subnet mask. If you shown in the figure 1, the IP address, the 3-dotted decimal IPv4 addresses must be configured when assigning an IPv4 configuration host. So this is the IPv4 address, unique IPv4 address of the host. Subnet mask used to identify the network or host portion of the IPv4 address. Default gateway identifies the local gateway local router interface before IPv4 address to reach remote networks. Which an IPv4 address is assigned to a device. The subnet mask is used to determine the network address where the device belongs. The network address represents all the devices on the same network. To identify the network and host portion of a network or IPv4 address, the subnet mask is compared to the IPv4 address bit for bit from left to right as shown in the figure 3. Figure 3. Left to right. Yeah. Note that the subnet mask does not actually contain the network or host portion of an IPv4 address. It just tells the computer where to look for this portion in a given IPv4 address. Logical end. A logical end is one of the 3 basic binary operations used in digital logic. The other 2 are or not, while 3 are used in the data networks. 1 and 1 is equal to 1. Example, 1 is the true and 0 is a false. 1 and 1, true and true is equal to true. If the problem have one false and the one false, the answer is always false. Like 0 and 1, false. 0 and 0, false. 1 and 0, false. It's always false. If the problem have 1 and 1, true or true, the answer is always true. And with the problem and the problem have a false, the answer is always false. Logical AND is a comparison of two bits that produce the results shown in figure 1. You may see the figure 1. I will the yellow highlighted sections in figure 4. That's the identify the AND bits produce a 1 binary and the AND results row. All other bit comparison produce binary zeros. IPv4 issues. The need of IPv6. IPv6 is designed to be successor to IPv4. IPv6 has a larger 128-bit because IPv4 have a low bit than IPv6. IPv6 have a higher bit than IPv4. However, IPv6 is more than just larger addresses. When the IETF began its development of successor to IPv4, it is used this opportunity to fix the limitation of IPv4 and include additional enhancement. One example of Internet Control Protocol version 6 is ICMPv6, which include address resolution and address auto configuration not found in ICMF or for IPv4 or ICMPv4, and ICMPv6 will discuss later in this chapter. Need for IPv6, the depletion of IPv4 address space has been the motivating factor for moving the IPv6. IPv4 has theoretical maximum of 4.3 billion addresses. Private addresses in combination with network address translation or NAT have been instrumental in slowing depletion of IPv4 address. Internet of everything. Internet is today significantly different than the internet of past decades because for now on, the internet is so very fast. No turtleneck. Because in the past decades, we have an slow internet, low bit, low RAM of our cell phones, no touch screens, no high gig of an memory card. We are lucky for this present. We are lucky because even we have a higher technology that we will use to get easier our work. Or although IP is only a best effort protocol, the TCP or IP suite does not provide for messages to be sent in the event of some errors. ICMP is available for IPv4 and IPv6. ICMPv4 is the messaging protocol for IPv4. ICMPv6 provides the same services for IPv6 but includes additional functionality. So this is the ICMP messages common to both ICMPv4 and ICMPv6. Host confirmation, destination or service unreachable, time exceeded, and route redirection. So this is the whole summary of chapter 7, IP addressing. There are many types of There are three types of IPv6 address: the unicast, multicast, and anycast. An IPv6 link local address enables to a device to communicate with other IPv6 enabled device on the same link and only that link or subnet. Packets with a source or destination link local address cannot be routed beyond the link from which the packet originated. IPv6 link local addresses are in the range. ICMP is available for IPv4 and IPv6. ICMP4 is the messaging protocol. Like I said, after it's implemented, an IP network needs to be tested to verify its connectivity and operational performance. So that's all for this chapter. Thank you for watching. Please subscribe and like my video. That's all. Thank you.